everyone. Thanks for joining us today. This is Jan Kenny speaking on the marketing team, and we are going to present today the Understanding HCL Traveler High Availability and Disaster Recovery Capabilities. And Wes Morgan and Casey Toole will be the presenting team from the Global Support Advisors Group. And in terms of housekeeping, this meeting is being recorded. The recording will be available shortly after the conclusion of this meeting at the same URL you used to register. So you can just return to that same URL and get the recording to watch it. Everybody in attendance will be on mute. If you'd like to enter a question at any point during the presentation, just click on the question mark icon. To the right of the question mark, there's a paper icon up there too. If you click on that, you'll see the PDF of today's presentation there that you can download. And then we'll, at the end, we'll have time to address questions and answers, maybe 10 minutes before the end. And we'll go over any questions that weren't answered in written form or any questions that require a bit more explanation or detail. So with that, I will turn the mic over to Wes Morgan to kick things off.
Thank you, Jan. My name is Wes Morgan. I'm part of the Global Support Advisor team for HCL Traveler. I'm joined today by my colleague and partner, Casey Toole. We've been working with Traveler for some years now, and one of the areas where we get frequent questions is about Traveler's high availability mechanism. How does it do what it does, and what can I do to make it function more efficiently? So we thought we'd spend a little time today and give you a little peek under the hood of how Traveler's high availability mechanism works and what option is available to you for disaster recovery. So let's just get started. Traveler provides high availability through a pooling mechanism, right? You create a group of servers, put them together in a pool, and treat them as a single entity. There are some rules. All servers in the Traveler pool must run the same release of Traveler. They must use the same Traveler database, whether it's SQL or DB2. They must have the same connectivity to your back-end Domino mail servers, and they must have full connectivity to each other. Those are the musts. There are a few should cases. They should have identical CPU and memory configuration. That's going to make workload balancing much easier. And they should operate on the same network subnet. In any case, you want them to be as close to each other and as close to the Domino mail servers as possible. Pools are limited to 10 servers, and a single pool will service roughly 12,000 devices. A big warning here, do not split your Traveler pool across a wide area network, or try to split it across your production and disaster recovery boundaries, okay? The reasons for that will become obvious as we look under the hood here in a few minutes. You can use an external load balancer in front of your Traveler pool. If you do, however, you do not want to assign session affinity, what's sometimes called stickiness, and you want to use just a straightforward round-robin distribution of incoming connections. So I've already said load balancing, workload balancing. Traveler actually does its own workload balancing within the pool. And we're going to take a few minutes and talk about what that looks like and how that works. It's based on the notion of a master monitor for each user, okay? So out of all the servers in your pool, one is going to be the master monitor for a particular user. It's going to monitor that user's mail file for changes. So right off the bat, you can see I may have 10 servers in my Traveler pool, but only one of them is tracking my mail file at any given time. This master monitor is assigned to the user the first time the device connects. And that master monitor server is going to handle all the transactions for its assigned users. Now, it's important to note, the user's network connection does not change. The device remains connected to whichever server in the pool it first connected to. The transactions, the workload, will be forwarded to the user's master monitor server on a separate connection. Okay, so there's a back end, a backhaul here. And now you know why the first recommendations were put all your Traveler servers on the same network subnet, right? Because they're going to be passing work back and forth on separate connections. So let's talk about assigning that master monitor. This happens every time a device connects. So the first question is, has this user been assigned to a master monitor server in the last 10 minutes? If it has, just automatically forward the workload, that transaction, to the assigned master monitor server. And we use this 10-minute minimum change interval to prevent thrashing, right? Because once you scale up to hundreds or thousands of devices, you're not going to gain anything by changing master monitor servers every 1 minute, every 2 minutes, every time the device connects. So let's say that the device connects and it hasn't been assigned to a master monitor server within the previous 10 minutes. What happens? Well, the server to which the device connected checks the Traveler availability index. Now, this is not the underlying Domino server availability index, right? Traveler maintains its own availability index. Well, it checks that for all servers in the pool. It adds a 10% bias to the server where the device is connected. And if there is a master monitor assigned, it adds a 20% bias to that availability index. Once it does that, it just looks to see which server has the highest availability index. In other words, which one is least loaded, and assigns that server to be the user's new master monitor and forward the transaction. Now, there's kind of a subtext here. The fact that we are referring workload back and forth behind the scenes means that the number of network connections on a server doesn't reflect the actual workload on that server. I might have 1,000 connections from 1,000 devices, but I might be passing the workload for 500 of those connections to other servers in the pool. So one of the old rule of thumb load measurement techniques, how many connections is it servicing? That doesn't really apply in a Traveler environment. You got to go a step further and look at the actual workload balancing. Another thing to note, a master monitor assignment lasts no more than 24 hours. If a device does not connect at all for 24 hours, any master monitor assignment it had will expire. So this is the case where one of your people goes camping for the weekend, they don't have cellular coverage, they come back into town Sunday night, the device connects, any master monitor assignment it had is long gone because they only last for 24 hours if the device does not make a connection to the pool. So that's a lot of words, but let's go behind the scenes. in your Traveler pool, you can use Tell Traveler HADR Show for the current state of the pool. And it's very straightforward. Shows the name of the underlying Domino server, the ID within the pool, the DNS name, the IP addresses and ports used, checks for the server being alive, the hardware, the network layer, the server, and the Traveler servlet. You see the availability index there. You see the number of users and the number of devices. Now, a couple of points here. Those numbers for users and devices are the number of users last seen on this server. Okay, same thing for devices. These are not live counts of users and devices being provisioned on that server. Okay, so you take the first server in this list, for instance, it says 2,315 users. That does not mean there are currently 2,315 users actively working on that server. It just means there were 2,315 users who last received service here. Might have been 5 minutes ago, might have been 2 hours ago, might have been 12 hours ago. But the last time that user hit the pool, this is the server that provided their services. Okay? Another note, the availability indices listed from this command do not include the biases I just described on the previous slide. Well, and they can't because that's a per user relationship, right? Because that bias will only be applied when I connect to that server, it'll get a 10%. If a server is my current master monitor, it will get a 20% bias. You might get different numbers, okay? So these availability indices don't include the workload balancing biases. Finally, in the help columns, is the server alive? Is the Traveler server responsive? Is the servlet responsive? Servlet access can be false for short periods of time, usually on a system boot or a Traveler restart. Now, if you see a servlet displaying false for a longer period of time, beyond a minute or two, you probably have a problem and you need to go check that server. So what does this look like in the real world? Well, here's a pool of 4 Traveler servers. I have a load balancer in front of my pool. It is not using session affinity, no stickiness, and it is simply doing a round robin distribution. So, user 1 at the top left, he comes through and this is a new device. It has no assignment. Or it's been gone for 24 hours. User 1 went camping this weekend and they just turned their device back on. Load balancer sends them to Traveler 1. Traveler 1 says, okay, well, they connect to me, so I'm going to boost my availability index by 10%. That puts me at 90. There is no other master monitor assigned, so now I can just compare all the availability indices. Oh, look, Traveler 4 has the highest at 92. So Traveler 1 will assign user 1 to Traveler 4 for master monitor. And as you can see, it will refer that workload to Traveler 4 through a back-end network connection. Well, user 2 comes along and they were assigned to Traveler 4 for master monitor 5 minutes ago. Well, the load balancer, doing its round robin, sends it to Traveler 2. Traveler 2 says, have they been assigned a master monitor in the last 10 minutes? Yes, they have, 5 minutes ago. Okay, Traveler 4 is still their master monitor, and it sends the workload to Traveler 4. User 3 comes along. They were assigned a master monitor of Traveler 2, but it was 15 minutes ago. So the load balancer sends user 3 to Traveler 3. Well, Traveler 3 says, I need to assign a new master monitor because it's been more than 10 minutes. I'm going to boost my availability index up to 95, 10%. They do still have an assignment for Traveler 2, so I'm going to boost Traveler 2's availability index by 20%, take that up to 110. Now who has the highest? Oh, well, it's still Traveler 2. So I'm going to reassign Traveler 2 as their master monitor and send the workload over there. And our final example, user 4 was assigned Traveler 1 as their master monitor 15 minutes ago. Load balancer sends user 4 to Traveler 4. Traveler 4 does the bias computations and assigns Traveler 4. And the workload stays there because now Traveler 4 is the master monitor for user 4. So that's what it looks like behind the scenes. So you can see that the workload's being passed around dynamically. Devices are being assigned to master monitor servers dynamically on a least loaded basis. And this all boils down to a one-sentence description. The device can physically connect to any server in the pool, but it logically connects to its assigned master monitor server. So now that we've seen how this is working, a lot of the requirements and best practices should be more clear to you. Why do we want all the Traveler servers on the same network subnet? Because all of these back-end conversations are going on to balance the workload. Why don't we want to split a Traveler pool across a wide area network? Well, that's going to introduce additional latency to all of these back-end connections that we see here. So at this point, you should be saying, right, I understand. We've got a lot of work going on behind the scenes among Traveler servers in a single pool. You should also understand why we say you don't want to use any kind of stickiness or workload balancing in your load balancer. You just want a round-robin distribution so that Traveler's built-in workload balancing can do its job. I just threw a lot of numbers at you, and I will tell you, you can modify this behavior. Before I go into details, I'm going to tell you I've been working with Traveler since it was first released. I've never had to change workload balancing to resolve a problem. Furthermore, I know of no instances in which this behavior has been changed in a production environment. It just works. So if you do decide to play with this, your first warning is you only want to make small changes. Because if you modify any of these substantially, it's going to have a domino effect. Because changing how the workload is distributed among servers in the pool tends to result in overloaded servers and underutilized servers. So having said that, here are the 3 points where you can tweak this behavior. You can change how long an assignment lasts for master monitor. You can change the bias applied to the local server, the server the device has connected to. And you can change the bias applied to any current master monitor assignment per user. You can change it, but if you have problems, HCL's first and only recommendation is going to be, okay, go back to the defaults and see if the problem reoccurs. We will not try to troubleshoot customized workload balancing. So this is definitely explore at your own risk. I only include it here because I've been asked about it. So if you can't really tweak the parameters of workload balancing, how do we monitor performance? Well, you can use what we call manual binds. And that means you can manually tie a user to a specific Traveler server as their master monitor. So going back to the diagram I had earlier with a 4-server Traveler pool, if I go to Traveler 1 and give the command, tell Traveler bind enable Westmore, from then on, all of my transactions will be handled by Traveler 1, no matter which server in the pool I connect to. And this will remain in effect until it is manually disabled. So until I go to Traveler 1 and give the command tell Traveler bind disable Wes Morgan, I'm going to be stuck on Traveler 1. If you work with this frequently, you may forget that you've bound people to particular servers. So if you want to see the bindings you've made across the pool, it's just tell Traveler bind show. And that will show you all the manual bindings that have been done. It does not show you all the dynamic assignments that are going on. If you want to see both, it's tell Traveler bind show all. And fair warning, that's going to list every master monitor assignment for every user. So be prepared for potentially thousands of lines of output from that command. One thing you might consider from a serviceability standpoint is that you could use binding to assign your Traveler support people to different servers across the pool. So Wes's devices, we'll bind those to Traveler 1. Casey's devices, we'll bind to Traveler 2, so on and so forth, which would give you kind of an early warning system, right? If I know I'm bound to Traveler 1 and I stop getting mail, calendar entries, etc., I'm going to know pretty quickly that I need to take a look at Traveler 1. This technique is also useful when you're troubleshooting, so that when Joe Public starts having problems with their device, you don't want to have to go look on every server in your pool to try to reconstruct the history of what Joe Public did. So instead, you configure finest logging for that user, or Joe Public, and then bind them to a specific server in your pool. So that way you know when Joe Public says, hey, my problem happened again, okay, you're bound to Traveler 1. I only have to go look at Traveler 1 to see what happened and what you did or didn't do. Remember to disable both the bind and the finest level debug after you've collected the necessary data. In the last version or two, I believe these came in with Traveler 9, we've added a few commands so you can test and observe the workload balancing. You can now move a specific user to a specific server without binding them permanently. So I can jump onto Traveler 4 and say, tell Traveler move Wes Morgan. Now, no matter what server is currently acting as my master monitor, that assignment will move to Traveler 4. Now, this is not a bind. So I'm not going to stay there. So you can expect to see me to be reassigned to other servers in the pool at some point. You can also force a new evenly balanced distribution of your users across all your live and reachable servers with command tell traveler balance users. So this basically does a reset of workload balancing. If you have 4 servers and 1,000 users, this command will put 250 users on each server dynamically. And again, we're moving them. We're not binding them in place. So you can expect to see them reassigned elsewhere as the workload progresses. But these 2 commands will let you take a 50,000-foot view of your workload balancing performance and basically do a reset and just evenly distribute the users across the pool. Again, this is not something that you would do on a routine basis. Traveler workload balancing is very solid, but these are commands that might be useful if you have a reason to observe workload balancing in progress. On the very first slide, I said that a traveler pool has to have all servers sharing the same database. That's actually the break point in what you can do for disaster recovery. And the best practice supported disaster recovery mechanism is to have a completely independent traveler pool at your DR site. There is no pooling across the production to DR boundary. There is no shared database between production and DR. And if you think about it, if I put my single traveler pool across production and disaster recovery, I'm expecting those DR servers to be up and available all the time. Otherwise, my pool is going to show a lot of unreachable servers, and that's going to hit performance. You can utilize domino clustering to cluster the back-end mail servers across that boundary. But Traveler needs to be a completely independent pool with its own database. Now, the next question most people have is, well, if that's true, what happens when I move everybody to my DR site? Well, the first time they bind, they're going to bind as a brand new first connection. And they're going to perform a full synchronization. But Traveler has introduced what we call adaptive initial sync. If you are currently a Traveler admin, you know that you can set an email filter limit. How many days worth of email will I maintain on each device? Well, adaptive initial sync says no matter what that configured email filter limit might be, I'm only going to let you get 1 day's worth of email the first time you connect. And then, as the server load allows, we'll work our way up to your configured email filter limit. Now, I know that most of you have users who want every piece of mail they've ever received on their mobile devices. Well, in a disaster recovery situation, what's more important? Giving everybody the last day's worth of mail or letting somebody get the last 6 months worth? That's where adaptive initial sync is a big win for your DR planning. Because the first time that device hits the DR site in a disaster situation, they'll get 1 day's worth of mail. which leaves server processing time to let everybody else get caught up with the first day's worth of email, to get everybody on the same sheet of music. Then, as things even out, if you have a longer email filter limit, devices will start picking up that backlog individually. So, you may have an email filter limit in production of 2 weeks. Well, your DR environment could be 3 days. Because during a disaster, your priority is making sure that as many people as possible can get current configuration, can get current communications, as opposed to this guy thinks he might need something from 2 weeks ago, a month ago, 3 months ago. So that's where adaptive initial sync is going to be a big boost in your disaster recovery plan. There are emerging technologies, especially in virtualization, where it may be possible to pick up your entire production traveler pool, move those virtual machines to another host, and just drop them back in place. Those are mechanisms we have not tested. They are not supported per se, and support for problems you may have using those techniques is going to be a best effort question, because we are not in a position to test every possible virtualization scenario. So our best practice recommended, fully supported DR procedure is the independent pool that I've described here. That's actually the end of our discussion today. You will be able to download this recording and the slide deck shortly after today's session. If you do have any questions, you can reach out through support channels to me or to Casey.